Good evening, everyone. Hope all are doing good. It is my great pleasure to introduce our esteemed speaker today, Cornelia, a distinguished data scientist with the AI/ML practice team in Generative. Cornelia stands at the cutting edge of technological innovation, specializing in advanced generative AI, machine learning, and data analytics. His expertise in these areas not only define his professional role but also his unwavering commitment to transforming data into impactful solutions. As we delve into today's discussion, we are privileged to gain insights from someone whose work was not only shapes the future of AI and machine learning, but also fosters tangible process progress and innovation. Please join me in welcoming Kaunalia. Thank you.
Hello.
Hello everyone, I hope I am audible now. Thank you very much. And I'm sorry for the delay. I'll make it up to it and I'll ensure that we don't have these hiccups and we will make the most out of this session. And first of all, welcome team. So today it's going to be, as in what are we going to discuss, right? Today I'll focus mostly on as in the foundational concepts of the artificial intelligence, as in how everything works, and then probably we will jump on to the Streamlit, as in using the Streamlit, how do we develop a chat application? And we will park some 5 to 10 minutes. I'll actually try to showcase with some examples, and then we will try to build the code together. Okay. So on that note, let's start. Um, so just a minute. Yes. So we'll get back to the stream data in the interest of time. What we'll do is we'll try to understand what is this data science all about, and what is this artificial intelligence all about, and uh, how do we try to understand, as in what are the analogies, right? And when we are saying we will build some application, or when we say an LLM, what's happening underneath natural language processing, and even before natural language processing, let's try to understand as in how artificial intelligence works. Okay. Again, I'm not going into the definitions of all this data science and data analytics, but understand that data science is encompasses artificial intelligence and also the machine learning that we talk about. Okay. So the core idea is this: in data science, what we do is we try to apply all scientific methods and techniques that are available to predict the future, right? The core assumption in this field is um, we can actually understand the patterns within the data, and we can actually predict the future within the patterns that has been seen in the past data, right? On that note, what is artificial intelligence? Artificial intelligence is, what we are trying to do is, instead of we trying to understand the patterns, we make the machine learn and understand the patterns. Okay. And how do we do it? Okay. That's that's the next thing. So for us, for us to make machines understand the patterns, or for us to teach machines as in how to understand the patterns, what scientists have done is they have taken a step back, and scientists started to ask or question that, hey, in order to teach machines, let's figure out how do I learn, how do I understand patterns, right? So people as in scientists have come up with three ways, as in one is supervised, the second is unsupervised, and third is reinforcement learning. Now let's deep dive into what each of these are. Okay, so first let's understand what is supervised learning, right? And supervised learning is that form of learning where we give examples and we take corrections, right? So, for example, let's say during our childhood, our mothers and fathers, what they used to do, as in when they are feeding us or when they are showcasing something, they tell us, teach us that, hey, this is a dog. And that example, they show various images of dogs, as in they show various figurines of dog and say that it is a dog. And whenever we tell that, as in that is not a dog, or we say tell that that is a cow or a deer, they correct us and say that, hey, no, no, that is not a cow or a deer, but it is a dog, right? That is showcasing with the help of examples. The same technique, which if we tell that, as in we have some data, we have some input, and this input has a corresponding output or a y, right? So as a label. So when we say that given this input, there is a label, and if you map it, then it's called a supervised learning. Okay, the first one, the left one. Okay, again, the input here is in our case, and we have an image, and we are asking if that image is a cat or a dog. As in, if it's just two classes, two labels, then it's called a binary classification. Okay, now, similarly, let's say if the input is, let's say, an audio, and we want to recognize that whose voice is this? Is it a voice of the countineer? Yes or no? Right? Again, it becomes a binary classification. So, whatever data that we have, and if we are trying to label it, we have already have label, and we are feeding that the actual data as well as the labels to the machines, and then asking the machines to learn these patterns and correcting it, and so that the machine learns finally as in what is the label, then it is called a supervised learning. Okay, and one request for all of you on the who are listening is that please drop all your questions on the live chat. So I'll take a pause, as in 15 to 20 seconds pause, for you to actually draft questions if you have any. And I'll take up after a few slides. I'll look at the chat, and I'll answer all of your questions. Okay. So that is supervised learning. And if you guys have any questions on how what is supervised learning, as in I'll give some 10 to 15 seconds pause for you to write any questions on the chat. Okay. Okay. So I'll also complete unsupervised and reinforcement learning, and then I'll answer any questions that you guys have posted on the chat. Okay. So we learned supervised learning. Supervision is, as in supervised, the name consists of supervision. We are saying that this is correct, this is wrong, and it is under the supervision of someone. As in here the labels. Okay. Unsupervised learning. I'll give you an analogy, right? You might have sisters or you might have some cousins who are just young kids, as in 3 or 4 years old, right? And those kids, so they don't, as in they will play with Legos, and Legos have a lot of colors, right? So I'm unsure if you know what Legos are, as in I'll show you how the Legos look like. So these are all the Lego blocks, right? The small things. So when you give a child, and when you ask the child to segregate that Legos, right? They don't understand what shape it is. is it a cuboid or a cube? They don't understand anything. But still, what they do is basis on the color, basis on the shape, they'll be able to segregate it properly, right? So even though without the knowledge of the cuboid, cube, they don't necessarily need to understand. They understand the pattern of the data they see. They understand the pattern of the images that they see, right? And accordingly, they segregate it basis on either the shape or basis on either the color, right? Both of them are correct. So that method of learning is unsupervised learning. Okay, we have data here. The Legos, in the Legos case, is we the Legos are the data, as in the image that we see is the data. Okay, we have the data. There are no labels, and our objective is we need to learn an underlying structure of the data. What is that underlying structure, right? And how are they? What is the pattern, and how can we segregate them basis on the similarity of the data? Okay, this is very much useful for us, um, and we will get to it in some time. Okay, this is unsupervised learning, and I'll take again a quick pause if you guys understood what unsupervised learning is, and if you have any questions, please do write down on the chat. Yes. So on that note, as in this is the second form of learning. One is with examples, second is without examples. Then you might ask, "Hey, Kaundinya, what is the third form? What is what is that form, right? And how do we understand?" So sometimes you might have seen some movies or some series, right? Some Hunger Games or um, those series, what happens is, or let me take an example, right? So earlier back in the day, what used to happen was, when we want to learn swimming, even now it's still practiced, as in when we want to learn swimming, what they used to do was they used to take us, our parents or our relatives, they used to take us to a pond or a well, and they used to push us into the water. Okay, nobody actually first taught us, as in you should move your hands or you should move your legs, and what is the front stroke, what is the back stroke. Nobody taught us anything, but we had to figure that out basis on, as in if we are moving our hands and moving our legs, then we are staying afloat, right? If we are not doing it, we are drowning. So that's why, as in, I need to learn and stay afloat, right, so that I survive. This is one form of reinforcement learning. So there are no examples, no supervision, nothing. We interact with the environment, okay, and we take an action. We get something as a response from the environment. Let's say if I'm moving my hands and I'm moving my hands and legs, then I'm staying afloat. As in, moving my hands and legs is the as the action, and me staying afloat is the response that I get from the environment because of my action. Basis on that, and if I don't do anything, I am drowning. That is the response I get from the environment. Accordingly, I'll choose my actions basis on the information that I get from the environment. Okay, so do we have data in the first place? Did someone tell me about swimming and the water in the first place? No, there is no data, nothing. I'm directly being thrown into the water or the swimming pool, right? And again, here, what do we want to do? What we're trying to do is we want to maximize our future reward over many time steps. Here, maximize the future reward. It's a extreme case, and we want to save our own lives. So that's why we are doing all this. So it can be many things, right? As in, let's say you're writing an exam, and and how do you maximize your marks with less preparation, or how do you retain whatever that you have learned over a period of time? All these examples doesn't fall under reinforcement learning. So Scientists have figured out that there are three ways of learning. One is we have we teach them by examples, give some examples and ask them to understand the patterns. That's one way. Second way is we have our innate nature to understand the patterns. Similarly, give the data and we ask ourselves to understand the patterns. Three is we don't have any data, nothing. We make the model simulate itself. We make the model go around the environment and understand how the dynamic works. In a way, whatever that we are doing in on the earth, right? As in what we are trying to do is we are trying to understand how our biology works, how the physics works, how the chemistry works. All these things is a kind of a reinforcement. And we are trying to understand how the nature works. So the third way is we are trying to understand the patterns using as in by interacting with the environment and understanding it. So that is reinforcement learning. I'll take a quick pause again and I'll see if there are any questions and I'll answer them. Explain supervised and unsupervised learning with a real-time example. Okay, so I'll explain this. It's a good question. So supervised learning and unsupervised learning. Let's say there is an email classification system. Okay, Let- the difference between the supervised and unsupervised is you have an email and it has been tagged as it's a spam or not spam. Okay, two classes. Okay, as in spam is something which is someone trying to bogus, as in it's that too repetitive one which is not no use. It can be fraudulent also. Not spam is the ones which are actually ours. And that's there. So that is if someone gives an examples already, and for each email we have a white label saying that it is a spam or this is a not a spam, then it is supervised. Let's say we are not telling anything, saying that, but we just give emails to the person or to the ML algorithm, and we are asking it to do that classification. It does not even understand spam or not spam. We say that there are two classes. It is for you to understand what are the two classes and understand the patterns and segregate into two classes which are look alike, right? Then it is an unsupervised learning scenario. Okay. So similarly, let's take the text example. Let's take an audio example. Okay. Let's say I have we have five voices. Okay. Voice of Kaundinya, let's say voice of Akhil, voice of Manaja, and the voice of Devi, and voice of Rudra. Okay. We have five persons. We have five different voices, and when I am feeding it to the model, I give a label, as in I give Kaundinya's voice and then say that this is Kaundinya's voice. Similarly, for Devi, for Rudra, and if I give all the voice samples along with it, the tags, then it is supervised learning. Isn't here focus is on the label Y. If we have the label, then it is supervised learning. If we say that there are five different voices, and we send it to the algorithm and say that hey, there are five different voices in the data set that's been provided. Now you see which voices are similar and bucket them into each group, right? So and if it is able to bucket it into five different voices, then it is unsupervised learning. Okay. So, okay. I see only one question. I hope. Are there any more questions? So, in the interest of time, I'll quickly skip. Okay. So, how do we train a machine learning algorithm? I'll just give skim through it, and I'll probably not go into the mathematics of it. So, what happens is just like we humans, let's say there is a typo, there is a mistake in the textbook, and you read the same textbook for your examination. Okay, and that is your only source of information. Then what are you going to do? As in, if a question comes, as in, um, let's say someone tells you that mm, uh, what is the right example? Let's say someone tells you that Revanth Reddy is the Prime Minister of India instead of the Chief Minister of Telangana. Okay. So if they say someone and you read that only book and you know for certain that there isn't you can confide in that book, then what happens is you're about as in you will confidently tell that Revant Reddy is the Prime Minister of India and not the Chief Minister of Telangana. That's not your mistake. And so the same is the case with the models, right? So if the data is incorrect and if the model has been trained on that data, then what is supposed to happen is what will happen is the models are going to learn false information. It's going to give false results. Okay, that is that is what is there. So when we have the data, as in again, why the data is required? The data is required because of the premise that um, we learn patterns from the data and we are predicting the future using the past data, as in whatever the historical data. So that's why we gather data. Once we gather data, we must ensure that the data is accurate, the data is clean. When I say clean, it is accurate and it does not have any factual misses or misinformation. And we need to convert that again data into a format that machines understand. Machines understands only ones and zeros. Okay, and how do we do that and how do we get that information is something again all these processes, right? And data transformation, data reduction, data sampling, all this process, as in that's called data processing, and that's what is happens when in that. Okay, we will see the NLP when we are understanding the NLP concepts. We will see that also. Once we have that data, we have the enriched data, which will divide into train and test. I'll give you the analogy why train and test is there. Okay, so let's take an example. If a student knows that the examination will be based only on the question textbook that he has been given, right? And when you conduct an examination only from those questions, do you think that the student is performing good? No, right? Why is that so? That's because as in there is a chance that the student might mug up those questions and really don't understand the concepts present in the textbook. So the same is the case with this machine learning models or artificial intelligence models, right? So we don't want to mug up, as in we don't want the model to mug up and replicate whatever it has seen. We want to the model to understand the concepts and scale it to the unseen data, right? So that is the reason we divide it into train and test, two different data sets. Within train, what happens is the analogy here you can think of is, so instead of waiting for the whole, as in, let's say again, take a student and you keep only one examination at the end of the year and say that you are a pass or a fail, right? So it is a little unfair. Meaning, if the student is not understanding from first month or second month, then we need to course correct and give some um, additional classes, or we need to change the way with which we are training the student, right? So that's why as in people keep some unit tests or some intermediate examinations, as in they can be mid semester or some class tests to understand as in how the students are performing so that we can tweak and we can tweak the curriculum or we can give more examples or put in more work. Similarly, for the models, what they do is after training, we will this is more of a curriculum. Okay, so in the training we will get some model, the model is being trained and we will do some evaluation. This evaluation is more like slip test or unit test, right? And then we take that feedback and again we change the update the curriculum. It's this is more of the analogy. So once we know that as in the model, as in the person or the model has been trained pretty good on all of the training data set, we then give a final test. The final test is of the model predictions, and we validate it, as in we will use the same evaluation criteria. And if it passes on even on the final examination, then we will say that hey, we have a trained model, and we will use this model for all the future use cases. Okay, this is how the machine learning workflow happens. And although it is given as a supervised or as in the classification is of a supervised learning concept, but it still holds good even for the training the large language models and other things. As in small things here and there, as in what pre-processing techniques and algorithms are used changes, but the concept is inevitably the same. Again, I'll take a quick pause, 10 to 15 seconds, to see if there are any questions. Okay, I see a question. How will the prediction mechanism work? I'm quite unsure what you meant by the question, the prediction mechanism work, but underlying it is a simple mathematics. Okay, so now that you have asked for it, as in, for example, the image here, the image here is converted into as in some numbers. Okay, some set of numbers. So when I say the model, so I randomly use the numbers, as in I randomly allocate some numbers, weights and biases, and I give some numbers, W and B. And finally, I say that as an I want to, let's say, predict only three images. As in, I want to say if it is a cat or a dog or a sheep. Okay. Finally, what I want is I need a highest score for cat, and high as in minimum score for dog and sheep. Okay. It should be highest score, as in 437 should have been here, and sheep. How can I take the values of in W and B such that I get highest score for cat and less score for dog and sheep? Okay, there is an optimization algorithms and other things in place. When I say prediction, the model is nothing but these numbers. Okay, it after seeing each example, these numbers get updated using some algorithm known as backpropagation algorithm. These numbers get updated, and when I multiply with the input, what the final answer that I get is it accurate or not? So the prediction here is this. Then when after all the computations and multiplications, what is the thing that I'm getting, and what is the highest probability scored? That's what is happening. So when I presume that when you say how the prediction mechanism works, this is again very simple. This is only for linear classification. If it is for transformers, there are encoder and decoder architectures, and there are, think of it in just this way, that there are multiple computations that are happening under the hood, and a series of numbers getting multiplied, and finally we will get one vector out of which we will say that, hey, this is my answer. That's how the prediction mechanism works. I hope I clarified. If not, please uh, write a follow-up question on the chat group. Okay. And I'll take a very quick stab at how the traditional machine learning used to work and what the deep learning works, how the deep learning works. Okay, so in the traditional machine learning, what happens is we were supposed to give, we used to give the features, and there are some ML algorithms, machine learning algorithms, using which the training happens. Okay, and that is a black box at this point of time. As in, please bear with it. As in, how that works is something. If you are interested, I will share those articles with you. And using the training process, those numbers get updated, as in the numbers that I have shown. And finally, we get the output, desired output. As in, if it is thumbs up or thumbs down, as in only two actions, that's what's happening. So there is some interesting concept known as neural networks. Okay, with the help of neural networks, what happened is we are not supposed to, as in, we did not have to do the feature extraction and classification, and it is automatically done by itself. And finally, we are able to get the output. How is this a game changer? Okay, I'll tell you an example. Even before the advent of computers, right? So take the example of Newton. Newton actually saw an apple falling down, okay, falling down on his face, and he was intrigued. He was surprised that, "So why did the apple fall down?" And there were a set of questions. How can I say, as in, uh, why did the apple fall down and not go up, right? And let's say if everything falls down, what is the speed or velocity with which it falls down? For example, if I throw an apple and a rock, both are falling down. Why am I having different impact because of them falling down, as in let's say they're falling on my leg. Okay, why is there impact? Does mass have a say in this, the velocity or the impact that I have? He had a lot of questions, and he finally wanted to get the Newton's laws of motion. He got the Newton's laws of motion, but what happened in between? What happened in between is he conducted a series of experiments. Okay, he conducted a series of controlled experiments. He gathered the data. He understood that the mass and acceleration and the force are the only three components, only three features that are dependent on this whole ecosystem. And then he understood the gravity and other things. But finally, he came up with F equals to ma. Okay, the Newton's second law of motion and other laws. I'm not describing it, but let's say instead of F equals to ma, and then instead of Newton figuring that out, let's say if there were computers and there is a mechanism by which we want to we are able to understand that F equals to ma equation, as in I give the mass and I give the acceleration, I give the force, then why don't I do it? Okay, this is where the deep learning helps. The deep learning actually is able to create that equation, and these models are able to create that equation and give it to us. Okay, that is the power of deep learning. And then we don't need to do the feature extractions, we don't need to give the mass and acceleration. We give mass, acceleration, and other things, other parameters get nullified automatically. That's one of the advantages of deep learning. Okay, and why are we learning this all deep learning and stuff? Okay, so it's because machine learning is a part of artificial intelligence. Neural networks is one way of approaching this machine learning problem, and deep learning is the bigger the neural network, the deeper the network is, and that the deep learning is that. Okay, so the deep learning meanings and neural networks, the bigger sizes of neural networks. Where does this generative AI fall? It is one form of deep learning wherein it is based on transformers and other architecture models, which is actually trying to generate new content. And if I give a sentence, it is trying to generate the next sentence. If I give an image, partially filled image, it is able to generate new image. So that is the generative AI. In this generative AI, again, there are image generation models, audio generation models, large language models. So large language models, the chat GPT is one. That is it. So that's why we were trying to drill down into the large language models. Okay, when we say large language models, it has something to do with language, right? Now let's try to understand what natural language processing is, as in what does this all what does this all mean, and what does it how is it relevant to us, right? Let's try to understand what is NLP, natural language processing. Very simply put, it is the process through which AI is taught to understand the rules and syntax of a language. Okay, so we know that it is, let's say, if you want to understand a language, if you want to learn a new language, we need to understand as in uh, the rules and the syntax. Let's say the rules and the syntax again differs from different languages. For English it's different, for Telugu it's different, for Sanskrit it's different, for let's say Spanish it's different, right? uh, how does how do we make a machine learn all these rules and syntaxes, and how do we use that learning from the machines and actually give that to as in actually make the machine do some the NLP tasks, the natural language processing tasks, right? For example, the language generation, question and answering, text classification, sentiment analysis, machine translation. Machine translation is more like I am talking in English, it should automatically translate it to Telugu, right? As in, and how, as in there are translators out there, but can a machine do the translation automatically, right? And there were scribes. And when you actually see United Nations, now that the technology is improved, now we have scribes. But let's say if you see the 1970s, 1980s, 1990s proceedings of United Nations, there used to be transcribers, or there used to be persons who used to convey the meaning from one language to another language, right? So As in, how do we make the machine learn those nuances? Language generation, meaning I give one sentence and can it generate the next sentence all by itself. Question and answering, if I ask one question, can the language model actually understand it and respond me back to the question I asked, right? Test classification, this is pretty simple. Given one chunk of text, can you say that as an what is the topic that is being discussed about, right? So that is simple classification. Sentiment analysis, if I give a sentence or a couple of sentences, can it actually say that as an, is it a good or a, am I angry, am I happy, am I content, right? Can it identify the sentiment? This is the problem that scientists had. how can we how can I make a machine learn and understand these concepts, right? So there are a lot of techniques. I don't want to bother you with a lot of technical details which you don't understand. There are two important techniques, and especially tokenization one and embeddings two. And I'll directly hop on to the transformers and how transformers work. Okay, as in these are the basic things that you are supposed to understand. Let's first understand what is tokenization. Okay, tokenization is again very simple process that takes raw data and converts it into some format, some useful data stream. Okay, in the context of NLP, natural language processing and natural language understanding, it's processing to split paragraphs and sentences into smaller units. Okay, and I say that the smaller unit is one word. You can say that the smaller unit is subwords, and you can also say that one other person can say that the smaller unit is character, right? Basis on that, so the left one is word based tokenization. If it is basis on word, as in we are dividing it, as in that's a word based tokenization. When we say the subwords, okay, I'm dividing the word further into the actual verb form and the noun form, and there are different techniques to it, as in lemmatization, stemming, and a lot of techniques. But the difference here is, let's say if it is learning, I'm again dividing it into learn plus ing. Okay, when I say learned, it's learn plus ed. When I say deep learning, again, I know this does not make sense, but they have done it as DEEP, two separate things, and learn plus ing. Okay, so if we are dividing it into subwords, again, this is another form of tokenization and subwords based tokenization. And finally, the deep character based tokenization, as in we are not even looking at the words or the subwords, we are looking at a character level. Okay, character base is not at all used anywhere, and it is only used in the OCR systems. But for natural language processing and understanding, we are not using that in any any place, because the character does not give any information on as to the meaning of the words. Okay, now let's go into vector embeddings. Okay, so what are these vector embeddings, right? So we humans have this understanding, we humans have this uh, rationale wherein we can understand five senses, five types of input, right? For example, we can see, we can understand something is with our sight, or we can listen, we can understand something with our ears, we can smell, we can understand the smell, and we can touch, we can taste, right? We have five senses, but the machines don't understand these. Let's say it can hear at this point of time, it can see is, and see is in it, the images is in one format, the hearing, the audio is in one format, the text is in one format. These are all different formats. Then machines understand only at the end of the day zeros and ones, right? Now how do I convert the the text or the audio, right, into a format that the machines understand, as in the zeros and ones? That is vector embeddings. Okay, vector embeddings are the numerical representations that transforms various forms of data into array of numbers. As in, you have something and you want to transform into an array of numbers, it's pretty simple. If that is called vector embedding. Okay, and especially in the NLP context, it this embeddings capture the semantic meaning and relationships within the data. Okay, I'll there is one more slide to explain this concept. But let's hold on and let's understand what is this numerical representation. Okay, so for example, king, man, woman, there are a lot of words here. I am saying that king is 4 comma 5. Okay, man is 3 comma 3.5. Okay, woman is 5 comma 3. Okay, and apple is 2.5 comma minus 2, so on and so forth. Okay, and why am I giving these definitions, why am I giving these colors, these definitions as, so as you can understand, king, man, woman are living things, living beings, right? And man and woman should be closely put together, because again king has something known as royalty, right, to him. But otherwise all three are living beings, and man and woman should be close together. When I say apple, banana, orange, football, golf, tennis, apple, banana, orange are fruits that we can consume. Okay, so they should be nearer, and they should not be jumbled with football, golf, tennis, right? Football, golf, tennis are something related to games, sports, right? So they should be in a different quadrant. Likewise, when we convert these numbers, and when I plot these numbers on a graph, right, in a 2D graph, so we want the words, similar sounding words, or the meaning that we actually give to the word should be in a closed space. They should be nearer and not far away. Okay, and that is, and how are we writing those numbers and to get that similar sounding words in the same things, as in that is embeddings, as in how do we do that as vector embedding technique. Okay, this is 2D example. In two dimensions we can actually plot and see. Let's say there are millions of words, and in one language, and likewise there are hundreds and thousands of languages across the globe, right? How do we put it in such a way that um, especially it's, if it's not two dimensional, if it's, let's say, n dimension, three dimensions, as in there it has another xyz axis. Likewise there can be n dimensions. Okay, n dimensions we can't visualize it at this point of time. You can just think of it in this way: when it is n dimensional, we have n uh, numbers in a single array, single uh, array. This array is also called as vector. Okay, so you can think of it as a singular row matrix with n elements. Okay, now let's understand, as in let's assume that, as in each of these values, as in what I'm trying to convey here is, as in how can it captures the semantic meaning and relationships, and how do we understand and how do we visualize it, right? So let's assume that cat. Okay, I am trying to categorize cat basis on these attributes. Okay, is it a living being, or is it a feline, or is it a human, or is it a gender, or is it something royalty, is it a verb, or is it a plural? Okay, so cat is a living being, yes. Is it a feline? Yes. Is it a human? No. And gender, with cat, I'm not sure if it's um, a male or a female, right? As in, so and that's why it's a lower number, as in, okay. And royalty, definitely it's not royal, it seems. But again, is a cat a verb? No. Is it a plural? No. Right. So likewise, as in assuming that the numbers are from -1 to 1, as in how can I represent the numbers in such a way that, as in the cat and kitten are, as in this 7 dimension, again you can forget the 7 dimensionality reduction for now, but idea here is how can I represent this in a vector such that it understands a lot of semantic meaning. Okay, so this is what happens with vector embeddings. Okay, you have a word, you convert this word into uh, each word, as in first we are breaking a sentences into words, that is tokenization. With from each word we are converting that again word into numbers, as in a set of numbers, an array of numbers, and I have some meaning to each one of the number represented in that array, and that is what is word embedding is, and how do we represent this cat in a set of numbers so that the machines understand, right? That is vector embeddings. I'll take a quick pause and I'll see if there are any questions. Okay, so I'll okay, I see there are no questions. So what I'll do is I'll move forward. So what happens with LLMs is, in the large language models, the GPT and other variants that you see is, it's it's been trained on a vast amounts of textual data, some millions and trillions of records. It understands the patterns, context, and structure of language. Okay, how? As in, we will park this asset for time being. And what it's supposed to do is, given a set of previous words, it predicts the next word in the sequence. Simple. So let's say I am telling about something. Okay, my name is Kaundinya, and I am a data scientist at Genpact. I I like, okay, when I say the previous context and when I say I like, it gives the most probable word given this previous context from the data it has seen. That's what LLMs all do. Any language model does it. It predicts just the next word. What is the highest probable word given the previous context, right? That is what is happening. Okay, and how do they do it? And it's again, there are two processes. The first one is called pre-training, and then it's called fine-tuning. What happens in the pre-training is, they randomly uh, mask mask is more like removing that word, and when you say would you tell me, and fill in the blanks, just like the fill in the blanks, would you tell me dash, which, again dash, right? When you say this, and we make the model guess, and if it guesses correctly, we give some positive point. If it guesses negatively, we will say that, hey, no, you have done a mistake, you should have written this. Okay, this is the training process. We have a mask test, and it happens some hundreds of times or thousands of times on the whole input data, and that's how the language models are learned. As in, we'll have a pre-trained model. Again, once we have the pre-trained model, we will fine-tune it on the data sets that the model might not have seen. We will give some additional definitions, and what we'll use is finally the fine-tuned model. Okay, and this is, I know it's a lot to take on LLMs, but again, if you have any questions, you please do ask. Okay. I'll take a quick pause again. If you do have any kind of questions, don't hesitate to ask. As in, don't hesitate and think that as in it's a silly question. It's a serious question. No matter what question, please do ask. And yeah, then please put it on the chat group. Okay. In the meantime, I'll take 5 or 10 more minutes uh, to showcase. Uh, as in Streamlit demos, and how can we create a chatbot, a very simple chatbot. As in, since you don't know about since you don't know about the language models and how to get the APIs, as in probably we'll take that. What we will do is we will simply create an echo chatbot. What I'll do is, we'll give it as a homework. How can you use APIs, and how do you use APIs to make a chatbot work up and running? Okay, let me pull that up, and in the meantime, Okay, I don't see any questions. Either you completely understood what I am saying or you did not understand anything. That is bad. Yes. I hope my screen is visible. Yes. So what we are supposed to do is again we are trying to create a small chatbot and let's see how that works. Okay. Uh, it's again always a good practice. Again, I'm just checking the Python version and let's see. And thanks for pointing it out to Zoom. So what I should do is it's always a good practice to create the virtual environment. You might have known about how to create the virtual environments, okay? And I'm creating a directory called um, creators of AI, okay? And what I'm doing is this Echo chatbot is within the downloads, okay? So what I'm doing is I'm moving this. Okay, now this is done, and let me open folder. I'm saying as okay. Now you see that that folder is here. Now let me go to the terminal again. Okay, so it's always a good practice to create a virtual environment. Okay, I'll just ensure that it is pip and virtual environment are up to date. Okay, looks like okay. Okay, the virtual environment package is already there. So what I'll do is, and I'm creating a virtual environment. Okay, once this is there, you can check it in two ways. Here, ls it's not there, then you can also check this .venv. Okay, when you're on Windows system, you need to write this command as in scripts slash activate. You need to run this when if you are on Linux systems and it's been activated. Okay, once the environment is activated, you see dot virtual environment here. Okay, and let me open the file and I'll go through the file one by one. And I know that this is Streamlit. You see that Streamlit could not be imported or resolved. That's because Streamlit is not installed in this Python virtual environment. And how do you change the Python virtual environment? Again, it automatically interpret it. If not, as in refresh it, you'll get a virtual environment. You select that virtual environment. Now I'm in this virtual environment, and I'll check if I'm in the correct virtual environment or not. Which, when I say which Python, it should give me the Python path that is as in creators of AI .v and we've been Python, which is good. I'm in the hmm, correct path. Now I'm going to install. I'm upgrading PIP as well as I'm installing Streamlit. Okay, while this is being done and while this is being downloaded, let's understand the code. Okay, so what we are saying is that in the Streamlit there is a title known as echo mode, and session state as that, as in we are importing Streamlit as st, and we are giving a title echo bot in this session state, right? So session state is that as in it remembers whatever happened within that particular web page, right? For example, if you are logging into Facebook or if you're logging into Instagram, you, when whatever likes that you're doing, as in you want it to remember, you want the Instagram application to remember as in whatever actions that you have done, so that as in you don't have to log in again, you don't have to um, like something again, you don't have to go back again, right? So as in, to understand that state, to understand that sessions as in what happened previously, right? So that is known as session state, and what we are checking is, are there messages in the session state? If not, if you don't have those messages, then initialize with an empty list. Okay, and we will see why those messages are important. Okay, so in the short way. Okay, now if there are messages, then as in what is the message role, we will come back to the role in some time, and we are writing the chat message, and we are writing it in the markup. Okay, and basically there are two major components in Streamlit, as in Streamlit, especially the Streamlit chat. Okay, to create a chatbot kind of interface. One is chat input, and the second is chat message. Chat input is the input that the application takes from the user. Okay, that's why it's an input, right? uh, so, and chat messages, once the input is taken, who is responding? Is it a user responding? Is it a assistant responding, the AI responding, right? Especially if it is in a bi-directional chat. Okay, so that is, let's say I'm changing this. Okay, and you'll understand this, the necessity for the for loop in some time. But once we take the user message, if prompt equals to colon equals to, means that if, as in if a user as in gives an input message, and if it is not null, then as in execute the if loop. If it is not, as in if the user did not give any input, and if it is if the prompt is null, and if it is not null, then execute. If it is null, then skip it. Okay, so again, if you type in an input message and if you give, as in the prompt will be the input given by the user, which is us. And what we will do is, we are saying that, hey, Streamlit, as in there is a chat message called user, and showcase that, as in a user has given a chat message, and showcase dot as a markdown, and showcase that on the screen. Okay, and we are also adding that to the session state under messages, and saying that we are appending, it's a, since it's a list, as you have seen here at line 7, this is a list, and that's why we are appending and saying that that message is given by user, and what is the content of the message is the prompt that we have given. Okay, and responses, we are just echoing, it's just a simple chatbot, it's not doing any APIs, right? So that's why we are echoing it, and we are saying as echo, and whatever we have given, and we are replying that back. Okay, and now what we are saying is that reply back that this is a message given by an assistant, some robot, which is trying to only mimic whatever that we are saying. Okay, and we are giving it as a response, showcasing it as a response to the application. And again, what we are doing is we are adding to the session state, and when we are appending it, when we are saying it as role assistant, as in we are adding it. So uh, now you understand the for loop. Like if there is a to and fro conversation that's happening, and if we have the session state, it will automatically process. It will automatically uh, understand what is the role here. Is it a user or is it an assistant? Okay, basis on that, it creates and showcases the content given by the given in the messages, as in the messages session state. Okay, now let me run the chatbot. Okay, I am not sharing the whole screen. Just a minute. I hope my screen is visible now. So what I have done is I have done Streamlit run and the name of the file, which is echo chatbot. Okay, then it creates two urls. It automatically pops up a url. If let's say the url is not popped up, then what you do is you copy that link. Okay, so it's localhost 8501. Okay, so it's an echo chatbot, right? You have this echo chatbot here, and let me say, how are you doing? It's again, as you can see here. Okay, so there's an echo chatbot, and I have asked, this is the user, this is an assistant, as in it says, how are you doing? Um, and again, it's replying the same thing. Okay, and let's say I'm asking what's your name. Again, it says that what's your name. Yeah, I'm just saying that you're awesome. Again, it will echo you're awesome, right? That's how what we do is this is more like an echo chatbot. Okay, and this is what we will be using. And for you to actually change this, for you to get a response from a language model, or for you to actually get as in send that prompt to an LLM, get the response from the LLM, and showcase it to the front end user. Then what you're supposed to do is you need to change this line 22, as in change the response. Instead of this echo prompt, as in you will make an API call. Change the response by making an API call and return that response, right? Again, I'll give it as, let's say, I'll give it as a homework. What you're supposed to do is, let's say if you're making an LLM call, and let's say, I'll say, and you take the user prompt, and you need to make an API call. You need to create a client, and as in you need to get call some method, and you need to return that response. As in you need to create, let's say, Hugging Face client, as in Hugging Face client, and you need to use a particular method, and take an LLM, and get that method and use that as a written response. As I am just keeping this as a placeholder for timing. So Hugging Face client dot, and you need to initialize and get it done. You get the response, and you will use that response here. Wait a minute. You will call that with prompt, and instead of this echo response, what you'll do is you will call the prompt, and you'll return that response. That is the one actually given by the assistant. Okay, that's how you do it. Let's say um, for now, as in to showcase that, as in whatever we write, as in it changes dynamically. Instead of echo, what I'll say, play. Okay, and let's say I type what game do you like? Again, see, as in earlier it was echo, I change it to play, and it's automatically reflecting. Likewise, as in what you're supposed to do is you need to make an API call to uh, an LLM, get a response, and showcase that response. Again, it automatically starts showcasing, and it will be something similar to the ChatGPT interface. As in, you might have seen the ChatGPT interface. If not, I'll showcase a very quick thing. And likewise, you can have the left bar also, as in this is okay. That's hidden at this point of time. That's okay. So you can see this like it's something similar to the ChatGPT, right? So that's about it. And this is a small demo, as in we will incrementally build on how do we use Streamlit to actually make an LLM calls, how do we plug in ASR models and other things for the duration of some time. But for today, this is it. And I know that I have taken a lot of your time. If you have any questions, please do ask. I'll stay back for a couple of more minutes to answer any questions that you have. Yeah, I see one question here. Just a minute. What will be the assign? What will the assignment be about? The assignment will be about a couple of things. As in, the your leads, the student leads will help you with that. Basically, it's like how do you create a small chatbot kind of interface using Streamlit, and two is how do you use the NLP techniques that you are learning right now, right? As in the tokenization and embeddings. Okay, there is a lot of techniques. Let's say, for example, word to vec and a lot of techniques how to use it, but that's for some other time. But how do you use chat kind of interface to do it? And all the details will be um shared to you in some time. As in, uh, don't worry about it. Don't worry regarding the assignments. Okay. and I realized that I was on mute, and I see that there are no more questions. So, thank you very much, and thanks for your time. Wish you all a very happy and enriching weekend. On that note, thank you. Bye bye.
If you have any other doubts, please post it in the comment section.
You are currently the only person in this conference.